the design of an orifice plate for a typical application. After reading the theory, you can click for simulator. The simulator will take you to the setup. Now in this setup there are 4 levels which you will have to go through. I'll demonstrate you level 1 only. In level 1 you are going to select what will be the beta value. The beta value which we have selected is 0.4, and the D is the diameter of the orifice plate, small d, and capital D is the diameter of the line. So you have selected beta as 0.4, D as 15 millimeter, and configure the system. That means confirm that the system which you want to test is like this. Say yes. Then in this case, if you expose this orifice plate in a pipeline, what will be the output? For example, if I select the flow as 335, I'll have to first calculate CD. So calculate CD, which is 0.6058. Now to solve this, you can check this formula and you can use this formula. All the equations are given over here. Discharge coefficients are given. The beta value you have already selected, and based on that calculate the value over here. It comes out to be 11279932.81. So I'll submit this value. Now this value is correct. Now I'll change the flow value, which is 447. For that 447, the CD would be 6055. Naturally for this, the delta P is going to change, which you will be calculating, and you will enter that delta P, and that delta P calculated is 20103060.88, and you submit this value. Then you calculate for one more reading, for example 646. What will be the CD? CD would be 6052. For that, calculate the value of delta P. Now this is the third reading. After completing this, you will go to the next level, and the calculated value is 420,28378.40. So submit the value. As you submit the value, you will find that level 2 has become active. You can plot this graph. You will see the graph is a non-linear nature of this graph. This is flow in LPM versus differential pressure is the graph. Now in level 2, if you click on to level 2, you will find that you can select a service for this. You can select any service, and then for example I have selected dilute HCl. All the values are given. Configure this, and then you will find that the flow change can take place. Similarly, you calculate for level 2 3 readings. Then you go to level 3 where you have different orifice taps, and after that, which is level 4, you will go to again back to the service, like you want to measure it for air or steam. So this way you can calculate and characterize the orifice plate.